Hey Gideon, yo, what's up? So, um, yeah, going back to the pillars of creation that we tried to align yesterday. So, I've been exploring this problem a little bit more. Why the alignment did not perform as well as we wanted, and so I discovered that the original images from the James Webb are actually the product of a mosaic of many different images. And so this mosaic results in some kind of distortion in the image. I mean, it's not one snapshot that you're trying to match onto another snapshot, rather a collection of images in a mosaic that you're trying to match to another collection, another mosaic of images in another image. And so let's go here to the um, the pixinsight application and see if we can improve them. So I opened here the application, and you can see that I'm back to the same images that I was processing before. So the reference image is our F090 image, and the image we're trying to align is the 187 image. And you can already see here that the main difference here is that I actually drew two preview windows, one on the bottom right and one on the top left. So this is called preview 1 and preview 2 in the reference image. And I did the same thing here. So these are more or less in the same place. And our thinking is that since we're now using a star detection algorithm using two preview images in each image, it should be able to pick up these distortions. Now, when we do the star alignment, and let me reopen the menu, so just to refresh our memory. So we go to the process, and we'll go to pre-processing, and we'll do our star alignment. So we're back in the same place, the same menu. And I'll make sure I set everything to default, so you see exactly which options that I'm changing. So I'll reset this. We're starting this menu from scratch. So I'm telling it which is going to be my reference image, which will be our 090W image. Note that I'm not selecting here the previews, but I'm selecting the original image. So that's fine. Now, the thing that we're going to do differently here is the following. So rather than using a projective transformation, which is assuming that we don't have these kinds of problems, and in fact you can read here in the description that the projective transformation uses homography and 8-parameter matrix transformation to compute source pixel coordinates. This method is appropriate for general image registration tasks with significant overlapping between registered images without differential distortion. And then we have the second option. Oops, let me go back there. The second option, which says thin plate splines, uses second order two-dimensional surface splines to interpolate source pixel coordinates. The surface splines provide for extremely adaptable registration models suitable for registration of images affected by differential distortion. Differential distortions arise frequently in mosaics and frames significantly displaced or rotated. So I think that's actually the case that we have here. So let's go to the thin plate splines. And we'll actually check here the distortion correction. We check here the local distortion. We check here the generate distortion maps. And we will disable the generate drizzle data for now. So these are the options that I'm changing. You're welcome to explore all these different checkboxes and see if they make any difference. But basically what I changed here is the registration model. I set it to a thin plate splines mode, and I told it to use a distortion correction, calculate a local distortion, because the distortion applies to both the reference image and the image we're trying to match, and we are generating a distortion map. So with that out of the way, I just wanted to check here that in the star matching section, the mode is set to restrict to previews only, which was set by default, so I didn't change there anything. And I think we're ready to go. So let's just see how that goes. So I'll drag my triangle here in my F187 image, and we can see it's working. So it's telling us that it's restricting the star matching to 2 previews. That's fine. So we got to the magical 83%, and it's continuing. So I found this process to be fairly stable. No crashes or hiccups yet. I did notice if you check this generate drizzle data, that sometimes it simply ends up with an exception at the end of the process, claiming that it is unable to find sufficient stars. So that's the reason that I'm unchecking the generate drizzle data option here. So I'm just waiting here for the process to continue. So it's reporting here on number of stars found, 3,000. Anyway, so you can see it's now iterating through all kinds of different trials, different ransack operations, and it did converge onto something. So that's all good. And just waiting for it to complete. So this is now a 2D surface spline length cost interpolation method. And let's see what we have. So somehow it calculated here 2 different images, one of which is a distortion map. And so you can see that, I'm sure we'll find some documentation on what this means exactly. So, but there do seem to be some, distortions, especially towards the top right and top left corners of the image. Now, we might keep this in mind when we do this again, maybe in a future version, where maybe we should, draw 3 or 4 preview images in order to get a better distortion map. So, but let's just minimize this distortion map for now, and we'll go to our generated image. Let me close the star alignment menu, and we're here in our generated image. Like always, we don't really see anything because this image hasn't been stretched. Let's do an auto stretch function for the screen, so at least we can get a general idea on the match that we created. So let me overlay this on the image, and just trying to keep my eyes on some of the features here, the main stars. And I don't know, I have the impression that it's a pretty good match. So let's just go ahead and reset this screen transfer function, and what I'd like to do is to apply some real stretching here. So we'll go to, let me see where that was, in the intensity transformations section. So we'll go to the histogram transformation, make sure this is reset, and we'll select our registered image, and I'll open a real-time preview. So this is the same exercise we saw several times before. So I'll do this in multiple steps. So I'll drag this on here. I'll reset the preview. I'll give it another try, and maybe move the black point a little bit. Trying to move here the mouse with my left hand, struggling with my mouse pad here a little bit. Anyways, doing my best. And so, as always, trying to restrict this histogram kind of like to the first half for sure of this range, and don't forget to apply it. And I think that's fine. Just reset this thing. And so we now produced an image that hopefully it's it's aligned better using this distortion map that we calculated. And let me just double check again. So I have the impression this is possibly a good match. So I'll save this as a TIFF file, save as, and I've actually been trying on multiple versions here, so let's not worry about that too much. So this is my 6th attempt, registered 6, and I'll save it. Make sure that it's a 16-bit unsigned integer. And it did save it. So let's just minimize this app and go to our Photoshop. Now, I already opened the reference image, so that's our 090 file. Already opened it here in the background layer. We might change the name again. So F090W, just to make sure that this is all the way at the bottom. So we'll add another layer on top. We'll go through the same exercise as before. Let's find our images in Scratch, Ariel. This is yesterday's, but that's okay. And I'm collecting my images here. So this was image 6. So I'll drag it on top. And we do have it on top here. Let's just change the name here so we don't get confused. So that's our F187, and this is attempt 6. So let's define our blending mode. I'll set it to lighten, I'm sorry. I don't know, sometimes my tongue does something different than what I'm expecting. So that's what we have. So let's toggle it on and off to see if we see anything that is obviously jumping, and we don't. I mean, everything seems to, on this 100% view, or the fit screen view rather, seems to line up pretty okay. But what I'd like to do is just focus on some sections here. Maybe really zoom in and start pixel peeping and see if here we have a better alignment. And just looking at all these features, I think we do. I'm pretty happy. I don't really see anything jumping. And let's go back and fit it to the screen again, and just pick another section, maybe here. So we'll zoom in here. We'll zoom in to 100%. And I'll enable and disable my view. And you know what? I'm actually pretty happy with the results. So we now have an answer to why originally the images didn't line up very well. And the reason was that our input images were distorted. And the reason that they were distorted is because the original images were produced by stitching together various input images. And this was done at NASA. They did that. So when they're collecting these pillars of creation, images, you know, at the end of the day, it's not one image, but it's multiple images, and they'll produce a mosaic. And you could see that in, maybe I should go back and, you know, open the original fits files. And let me do that. So going back to our screen, what I'd like to do is go back to my folder, and I'll open here another image. Here, the 200 F200W image. So I'll right click on it, I say open with, I'll open it in pixinsight. And it's a big file, so again that's going to take a few seconds to open. 14,000 by 8,400 pixels, so quite large. And just wanted to show you, you know, all this mosaicing in the original source files. Just wait for it to finish. It's almost there. We already know that when we do this, we'll see multiple images. So here they are. I'll just close a bunch that I don't really want to show. But here you can already see that there's this mosaicing going on. You know, there are multiple images that were overlaid, and you see the same kind of thing here. And in fact, there are probably quite a few images in general. You know, maybe these different colors are a representation of how many there are, but it looks like there are, you know, at least a dozen or maybe a few dozen images that were used in order to produce the final image that we're getting from NASA itself. And let's see what this is. Auto stretch. Yeah, so here you see exactly what is happening. So the image has been produced by mosaicing together all these images that have some kind of, you know, like some kind of overlap there. But apparently this mosaicing process that NASA has used is not perfect, and so the final image has some distortions. And the way that we were able to overcome these distortions is by defining, and let me minimize this, and go back to the original source image. So the way we were able to overcome these distortions is by defining two different preview windows, and by, when we're doing the star alignment process, here in the pre-processing star alignment, by switching the registration model from projective transformation into the thin plate splines transformation, and checking here a few checkboxes. Know that we want to apply a distortion correction, that we do want to calculate a local distortion map. So just hovering over this, you'll see when this option is enabled, the distortion correction task is performed in two steps. The first step builds a global distortion model from the set of matched stars. The second step generates a local distortion model using the whole set of detected stars. So what this does is using both images to calculate the distortion model. Because you might have another situation where the reference image is not distorted, and any images that you're trying to match to it are distorted. So in that case, you wouldn't be selecting this local distortion image. So anyways, I think this is a nice finding. It took quite some effort to get to this point. And I know in this case I just showed how to match two images. And we do remember, just going back to our file manager, that we have 6 images we need to match. So to do that, we'll just need to follow this same process and process all 6 images. So that's it for now, and I hope this was useful. And I think in the next video I'll try to match all these 6 images together and see if we get a better match, better alignment in Photoshop to produce our final output image. So thank you for your attention and keep smiling.